In order to build a web search engine, you also need to build something to populate that engine, namely a web crawler. A web crawler is really a very simple thing. It's something that traverses the web graph. So it's very simple. Here's a 4-line program to build a web crawler. Start with some URL, and we have a recursive function crawl. It fetches that URL into a variable called doc. And then for each href, which is to say each link in doc, we recursively crawl that href. And we basically keep doing that until we have visited all the docs reachable from that URL. Okay? That works, but there's a bunch of things about it that don't work well. And we're going to go through some of those things in the following slides. First of all, you'd better not sit around waiting on each fetch. As you know from clicking around the web, fetching a URL takes a little while. Computers are a lot faster than that. So we better do something clever and not just sit around waiting for each fetch to return sequentially. We'd better run this thing in parallel on many machines because the web is really big, and if we have any hope of crawling it, we're going to need to use multiple machines to do it. We'd better be polite. That's in the sense that we don't want to fetch from the same IP address, the same computer, over and over without interspersing fetches to other computers. Otherwise, we'll overload the one computer we keep fetching from, and that's not polite, and they may block us in future. Another issue we need to deal with is we probably won't finish crawling the entire web before the documents on the web change. That's just the nature of the web. Things change faster than a full crawl will take. So we need some notion of a revisit policy that's going to revisit pages that are likely to change. And then finally, there's all sorts of yucky details about dealing with the actual details of URLs in the web, like dynamic HTML that's auto-generated, even adversarial auto-generated HTML that's trying to trap our crawler by creating interlinked pages that just go deeper and deeper dynamically for the crawler. Another issue with URLs on the web is that some of them are identical. There are mirrors of the same site, and we may not want to search all of those, or at least we may want to deprioritize some of them. So we'll go through some of these details over the next few slides. Let's start by building a single site crawler. And the basic idea to start with is to get some outstanding fetches going and not have sequential fetches, the first bullet from the previous slide. So we want to have multiple outstanding fetches, and we want each one of them to have a modest timeout. And we don't want the remote site to be able to choose the timeout because the remote site might take a very long time. And so we want to control how long we wait for a fetch before we give up on it. So typically this is done with some multi-threaded components where each fetch is assigned a thread, and the thread has a timeout, and eventually if the site doesn't respond in a reasonable amount of time, then we reallocate that thread to doing another fetch. All right? You can typically actually implement this in an even better way than multi-threading by using a single-threaded event-driven approach. And this is kind of like doing event handlers in a language like JavaScript, but you're doing it for your back-end code. You're doing it for your web crawler. And if you didn't understand that, that's fine. It's something you can learn about when you do a parallel programming class. If you do a bunch of outstanding fetches like this, then at any given time, your crawler has a sort of set of these pending fetches it's waiting for. And this is what may be called the frontier of your crawl. This is the edge of the things you've seen so far. And this can grow to be very, very big because as things expand, they'll expand exponentially into a wider and wider branching of nodes to fetch. And so you're going to need to manage this wisely to pick the next sites to fetch. You can't simply go breadth first. And so what traversal would a simple first in, first out queue for fetches give you? And is that a good traversal?